Thank you, Geo. Appreciate it. Hello, everyone.
Oh, yes, you're on.
Good evening. So, in celebration of lots of 50th anniversaries, I wanted to look a bit at this notion of whole Earth. The 50th anniversary of the Whole Earth Catalogs publication is coming up this weekend, actually, in San Francisco, and it celebrates this legacy of what it means to be able to see our planet from the perspective of this God's eye view, which this particular story started in 1966 when Stuart Brand was 28 years old. He was sitting on the top of a building in San Francisco, dosed on some LSD, and he was ruminating on a lecture that he'd heard by Buckminster Fuller, thinking about the curvature of the Earth looking over the ocean, and he was wondering why hadn't we seen a photograph of the whole Earth yet. So he made these buttons, being the provocateur that he was, and shortly thereafter, that age-old quest, the Apollonian quest for a God's eye view, actually became a physical reality. That photographs of Earth from space began to transform. They were transmitted first back from satellites, later back from astronauts, to transform perspectives on our home planet. But tonight I'd really like to look at the ways in which it had unexpected and even paradoxical consequences. Because we all are familiar with the narrative of it, showing Earth as an interconnected system, to provoke lots of questions about humanity's relationship to our home planet. It was really one of the more profound images to, I think, affect the collective psyche. And then astronauts aboard Apollo 8 in 1968, a year later, took this unexpected photograph that wasn't scheduled in any way. And there's a brilliant documentary that was just released on New York Times about this process of how this photograph was taken, highly recommended. But these images have achieved like near religious status, because some astronauts like Edgar Mitchell claim that this resulted in this kind of cosmic epiphany, proclaiming that it induced a shift in consciousness for them, that they essentially their ego boundary dissolved into the cosmos and they could experience themselves as the eyes of the cosmos. He actually came back and started the Institute of Noetic Sciences. And then a few years later, Apollo 17 astronauts broadcast this now famous blue marble image, which for many lots of folks, I think, hoped and proclaimed that it was the initiation of a paradigm shift. That even Joseph Campbell, when he was talking about this, referred to it transforming and deepening and extending human consciousness to a degree and manner that it opened a new spiritual era, he believed. And this was really celebrated in the context of popular culture. Carl Sagan talked about it extensively. It was really given birth to kind of, accredited with giving birth to modern ecological consciousness. Well, today, we kind of take it for granted. It's actually not that big of a deal. It's either been appropriated by lots of corporations as a sort of symbol of globalism, or most of us are busy, maybe exploring the novelty of our rooftops on Google Earth, right? So this sort of novelty of this image has really faded from consciousness in many ways. And that's really what I'd like to look at tonight, because it used to be that this image was really associated with understanding whole systems. And in fact, this was the first page of the Whole Earth Catalog itself, and it tacitly drew this connection between being able to see the whole Earth, thinking of the health of the whole, and really trying to catalyze an understanding of whole systems. You turn to the second page, and it was all about Fuller himself, which he was really giving credit by Brand for the insights that initiated the catalog. And as Piero mentioned, Fuller's archives are here at Stanford. He kept a really quite a detailed log of his life, almost every aspect of his life, between 1920 and 1983 when he died. It's composed of this archive called the Chronophile is composed of over 700 volumes. I think it's something like 1,400 linear feet. And according to the archivist here, his was the most documented life in history prior to the internet. And he refined his approach and his understanding through a half-century-long experiment in which he wanted to see what one person could do on behalf of all of humanity. He had kind of a personal mythos around this, where he's going to kill himself, and he heard this voice, and it really challenged him to engage in this experimentation. So over the course of his life, he published 23 books about history, geometry, cartography, poetry, future studies, design, cosmology. And he was really into the idea, and this is what influenced Brand so much, of gaining a degree of mastery over tools, of creating prototypes, of actually making things, not just philosophizing, but mechanically applying the philosophy. He was actually granted 28 patents for automobiles, boats, shelters, cartography, had 47 honorary doctorates from around the world. But one aspect of his explorations that's relevant to this notion of the whole Earth was his desire to visualize the planet in new ways. In the 1920s, he started trying to visualize and imagine what was going to be required for shelter to house an ever-increasing population of humanity. And he started keeping track of data at that time to try to understand the curves that would be occurring in terms of the quantitative understanding of planetary phenomena. This was a graph that he published in Fortune magazine in 1940, looking at energy consumption, the power to consume, efficiency. You know, this is really before we take, again, these types of graphs for granted now, but this is before many people were collecting this type of data on a planetary scale. And of course, today we're quite familiar with these graphs. Starting around 1950, we see what's commonly being called the beginning of the Great Acceleration, where many, many vectors of activity and phenomena have been more or less exponentially increasing. Fuller took all of this data in the 1960s, compiled it into what he called the Inventory of World Resources, Human Trends and Needs, to create this comprehensive inventory of what it would take to, in his words, make the world work for 100% of humanity. And he spent a lot of the 20th century trying to lay the groundwork for creating a display that would enable visualizing this phenomena. This was him, these different phenomena. This was him back in Black Mountain College when he was teaching the summer school there in North Carolina, experimenting with early prototypes of his geodesic domes, which then later became these geodesic spheres. And he started to envision what he called the Geo Scope, creating prototypes of these throughout the 40s, the 50s, and the 60s as a way of visualizing planetary data. This was an illustration done for him of an idea to put one outside of the United Nations that he also called the mini-Earth, that he wanted to have the delegates to be able to see the invisible trends of the planet, to be reminded every single day of their own responsibilities. And in his 1962 book, Education Automation, he described the geoscope as a giant 200-foot diameter miniature Earth that would enable the most accurate global representation of our planet ever to be realized. He proposed one of these for the 1967 US Pavilion in Montreal. And he had lots of ideas for this. One of the ideas was to cover the surface in variable intensity light bulbs so that there could be sort of visualizations of planetary metabolism as opposed to individual metabolism, so that we could understand the flows across imperceptible scales of time and space and frequency. And he also envisioned on the inside of this what he called a World Resource Simulation Center, so that individuals, communities, and world leaders could come together and sort of play the antithesis of a war game, something that he called the world game. And he used these prototypes in this particular cartographic mapping he developed called the Dymaxion to look at the Earth as one ocean and one island, to try to understand through visualization techniques how it was that we could begin to imagine our planetary system as a whole system. So speaking of 50th anniversaries, in 1969 he published Operating Manual for Spaceship Earth, calling for a new ecological awareness to radically transform perspectives on planetary stewardship. And fast forward 50 years, today that's become quite a trope, particularly within the arena of remote sensing. That it's a widely used metaphor. It was throughout the 1960s, but it's starting to make a bit of a resurgence. Next year is the 50th anniversary of the publication of the book, and I think it's worthwhile revisiting some of these ideas, because the fruits of the space age have really enabled a lot of the visions that Fuller had back then to become reality, to the degree that we can take much of it for granted. That we're surrounded by these webs of Earth observing and communication satellites that provide significant impacts into the influence of human civilization on our planetary biosphere, on our lithosphere, on our hydrosphere, in such a way that it essentially extends our perception. These satellites, these remote sensing devices, are acting almost like sensory prosthetics, whereby we can begin to see phenomena across spatial scales, zooming in and out like powers of 10. We can see things across the spectral scale, so we're extending our perception beyond the very limited range of the visible spectrum of electromagnetic spectrum. We can look across temporal scales to see things occurring over time. And my favorite, we can really start to imagine things across relational scales or trophic scales to see the ways in which things are actually interconnected, which oftentimes are very difficult to visualize, but I think the most important in terms of storytelling. Some examples of this are things like the breathing of our planet. It's not a metaphor to call Earth alive. Like there's literally this what's called net primary productivity that we can see, that is the daily and yearly cycles of our planetary system. That this is a cycle of CO2 and oxygen exchange that's absolutely integral to all of our existences, just like we heard about our own synchrony with the various cycles, both at the planetary and cosmic scale. Here we see visualizations of satellite observations of surface flow and wind currents, which were done by NASA to demonstrate how fresh water moves in vortices between the ocean and the atmosphere. And here we can see how ocean currents are distributing solar energy to regulate the Earth's climate. The planetary temperatures are really equalized by cold air and surface waters that are moving towards the equator, and warm air is moving towards the poles. And the circulation is what stabilizes ocean temperatures and atmospheric temperatures. And here you can see sort of the conveyor belt in the Atlantic Ocean, and why it is that Europe can remain so warm is these warmer currents sort of are drawn down into the deeper ocean depths. We can also trace animals to visualize their migration patterns, just as we could with humans, but this just happens to be a visualization of storks migrating to Germany, from South Africa, where they migrate on a yearly basis to reproduce. And this is a visualization of flows of phytoplankton with currents in the global ocean. You can see the different species of phytoplankton here, as well as their distribution, which is largely based on ocean temperature. So since they serve as the foundation of much of the ocean food web, you can imagine that shifting ocean temperatures has a pretty radical effect on the ways in which other species of animals would be migrating, because they would be dependent on these different types of phytoplankton. And these hyperspectral imagers of satellites can also enable us to see very complex interactions between human-induced phenomena and the planetary biosphere. For instance, we can see here different sulfates from industrial pollutants. We can see organic and black carbon coming off of the burning of forests. We can see dust. I'll give you a different view, an equal rectangular view. We can see sea salt coming off of the ocean. And what's remarkable about something like this, looking at it over scales of time, here you can see the time scale up here, that you see all of this dust coming off of the Sahara and the Sahel, mostly diatoms from dried up lake beds, which are then coming across the Atlantic on the currents, which are then being dumped into the Amazon, which are then seeding the Amazon, which is then through a process of evapotranspiration, really inducing much of the planetary hydrological cycle. You can also see the trees burning in the Amazon, and then the DCR and the Congo and in Indonesia. You can see all the sulfates coming off of Shenzhen and different factories in China over there, as well as factories in the US. But just like the impulse of looking at the whole Earth image and saying, hey, we don't see any political boundaries, we're all unified, that these new sensory extensions that we have show the profundity of the truth of that all of these various flows and metabolisms are deeply, deeply entangled with one another. This is a visualization from a friend in Montreal looking at human infrastructure, in this case shipping lanes and power lines crisscrossing the seas. And this is some of the imagery from NASA's lights at night, so that you can see the degree of electrical infrastructure, which is also kind of an indication of population in various countries. One of my favorite applications of these tools is one called the Global Fishing Watch, which is using satellite data and crowdsourcing to essentially track vessels in the open ocean. And really checking on if they're doing what they're saying that they're doing, because there was no way to monitor the global commons before we had these satellite systems. And what they're discovering is that there's a tremendous amount of illegal fishing going on, and oftentimes the ways in which they're funded is through subsidies for their fuel, and if you actually run the numbers, nobody is actually profiting off of this, other than the people running the ships. And they're actually increasing the bycatch and the overfishing so much in the oceans. We're essentially like, sucking the oceans dry of life for no real reason. I mean, it's extraordinarily inefficient. So this is starting to be adopted by many countries. Indonesia has really taken this up, and they've been exploding illegal fishing vessels because they can now monitor their own exclusive economic zones. There's another consequence of this, of course. It's not all good in terms of the satellite industry. Here we see a simulation running out in time of the space debris, looking at what the consequences are. These are, of course, a bit exaggerated, so it looks a bit scarier than it is, but it's pretty horrifying. The consequences of what's happening as we're launching all of these satellites without sort of planned obsolescence time so that they come back down to Earth. And it's really limiting the future of our capacity for launching things into space, given the complexities of what happens when these things run into each other. And we've also seen gravity and the dangers of that. One of the things I really appreciate about these kind of fruits of the space age is the degree to which it's revealing synergies that we did not previously recognize. So for instance, this is one of my favorites, a visualization from ESA of Earth's magnetic field. It was one of the first things discovered when we started sending up Earth observing satellites. This is essentially like iron filings around a magnet when you're a kid. It's creating this field because of the molten core at the Earth, we believe, that's really protecting our planet from the from the solar winds of the sun, dominantly protons bombarding our planet. And this field is really acting truly like a spaceship. It's protecting us in such a way that our atmosphere and our oceans could evolve over time, and that it wouldn't get blown away. We recently sent a probe to Mars a few years ago and discovered that the magnetic field there was extraordinarily weak. So this is one of the primary reasons why we have a habitable biosphere. And of course, through the search for life on other planets, we've also discovered that we live in the habitable zone of our own solar system. This is the place where it's sometimes called the Goldilocks zone. It's not too hot, it's not too cold. The temperatures are just right for liquid water to exist on the surface of our planet. Now this is easy to take for granted. We've evolved here, but the more we're looking for life on other planets, the more we're realizing that this is an extraordinarily important aspect. Most of the time when we're looking for exoplanets and looking for what oftentimes, Earth 2.0, it's because we're finding a planet roughly of our size in another solar system that's in the habitable zone. But that oftentimes doesn't take anything into account with regards to all of the other synergistic conditions necessary for the evolution of complex life. One of the things I like about visualizations is they can show us how extraordinarily ignorant we are. Does anybody not recognize what this is? This is the solar system, right? You've all seen it, right? It's the solar system, of course. Well, in '75, Fuller was trying to demonstrate the degree to which we are extraordinarily ignorant, that even in the context of our own solar system, we tend to think of having a static sun. That ever since Copernicus, we've had this story of Earth shift, the center of the universe is no longer Earth. The sun was the center, as Copernicus was proposing. But Fuller was arguing, no, actually, in this particular case, reality is spiral orbital. All terrestrial critical path developments inherently orbit the sun. No path can be linear. All paths are precessionally modulated by remotely operative forces producing spiral linear paths. Get that? Typical of his dense language, but it's a lot easier to visualize this. So we exaggerated the scale of the planets and created this visualization for the COP21 meeting in Paris, just to demonstrate the degree to which our sun is traveling around the galactic core of the Milky Way relative to that galactic core at about 500,000 miles an hour, while we're spiraling around the sun relative to the sun at about 60,000 miles an hour. So we can begin to understand how outdated so many of our views of not only our planet but of the cosmos actually are by actually trying to enact these visualizations. One of my favorite examples of this is the Digital Universe Atlas from the Hayden Planetarium. They basically aggregated and curated data visualizations from astronomical observatories all over the world, put them together, created a real-time kind of powers of 10 engine inspired by Charles and Ray Eames, so that this is a very quick, sped-up version of a zoom out to the outer edge of what we can see. Here we see Earth, all of its satellites, the moon's orbit, still the static sun, but still the orbits of the other planets. As we zoom out to a travel of a light day, we start to see the constellatory lines, which then start to collapse because it's a three-dimensional relationship of the stars to the Earth. We see the radiosphere. We see a model of our own galaxy. Every single dot we see here represent other galaxies with hundreds of billions of stars. Here we see big blind spots of things that we can't even see because of all the gas and the dust in our own galaxy, out to the outer edge of what we can actually see, which is called the cosmic horizon in time and space, or the cosmic microwave background. Got that? So, this is a model of the cosmos, based on our contemporary cosmological theories. This is, from an observational perspective, this is what it looks like. Anybody notice something funny? This is one of the great ironies of our time, and this is what I mean about the paradoxes of actually trying to visualize where we are. Because in this new model, of the past 500 years, we had a story of the scientific revolution catalyzed by the shift away of Earth from the center of the cosmos, and here we are with $10 billion worth of data, once again to find ourselves at the center of our cosmic model. Now, of course, there's a very simple explanation for this, which is that we are at our observational center. When we look out into space, we are looking at light that's been traveling for different amounts of time. And so when we model that light, we actually model it along these axes so that the further back in time we look, the further out this light has been coming from, right? So we're essentially, this is the earliest thing we can see, and the closer in we get, the closer in we get in time. Now, I think that that's so uninteresting to astronomers because it's such a given, but I think what they've missed is that the other aspect of this is that Earth is our ecological center. That what we're discovering as we look for complex life, or any life in other places, is that the synergistic conditions here truly are extraordinary. That we assumed that we would be able to go to all of these other places without much of a problem until a few decades ago. And the more that we start to understand this planet and who we are and our own circadian rhythms and our own metabolism, the more we're coming into the realization that we're not just on Earth, we are Earth. We are the self-conscious functioning of a constantly evolving and collaborative biosphere. That we humans can now reflect back on ourselves and realize that this is the only place we've discovered that supports life. That might change at some point in the future, but the more we're looking from an astrobiological perspective, the more remarkable this place seems to be. So I think that, in sum, the reason that it's really helpful to start to transform our worldviews and how we're seeing and expanding our perceptions and imagining our planet is so that we can begin to act like we actually have the knowledge. This is an extraordinarily special place to be. Thank you.